In this video, I'm going to use the TI-89 again to show you how to find the zeros of a polynomial. Now, a zero is simply a value that gives you a zero if you replace the variable by that particular number. Okay, so we could actually use the technique that I used in an earlier video dealing with equations, because that's all you're doing. I want to know when is 10x squared. When is 10x squared in this case? A polynomial is p of x equal to 10x squared minus x minus 3. So all I want to know is when is 10x squared minus x minus 3 equal to 0. So I could solve that as an equation, just like I did in one of the earlier videos using TI-89. But we're going to use the zeros command. So I have the TI-89 here, and I hit the F2 key, and I go to, there's zeros right there. Okay, so I could use this command, zeros parentheses, but sometimes when you're finding the zeros of a polynomial, your instructor's going to want you to find all the zeros. So that means the non-real and the real. So if you use this command, it's not going to give you the non-real zeros. So similar like with equations, I'm going to go over here to complex, and then we have three options here. Here's the one I use for the equation, C solve. In this one, I'm going to use C0, so hit number 3. And then I simply enter the polynomial. So 10 x squared, little caret and 2, minus x minus 3, and then a comma, and then just like with equations, I have to give the variable, so hit x and then parentheses, and I get the zeros of -1/2 and 3/5. Okay. Now in an earlier video I solved the same problem, except that this was an equation, but you can see the solution is the same as a zero. So the solutions of the equations in that earlier video is the same as the zeros of the polynomial. So -1/2 and 3/5. Okay, so put this up, and then I clear this, then I go to the right, and then so I don't have to go to the command, I'm just going to clear what I have there. Clear this out. And then I'm going to go over here to the next one. Okay. X squared. So I want the zeros for this polynomial. So again, the caret, x squared plus x plus 1. And then comma, define the variable, so it's x, and there you have it. So -1/2 minus radical 3/2 times the I. So this particular one has two non-real solutions. The other one is -1/2 plus radical 3/2. And then I go to the right here, go up here, go to the right, and you can see the I there. Okay. So I get two non-real solutions. Okay. Let me clear this, and then I get this time I'm going to clear the whole thing, so you make sure you have the steps here. So we'll hit the F2. Let me go to the next one. So F2, and again, just to show you that in this one, just like in the one we did in the last video, if I just use the, well, let me go back. If I just use the zeros one, number 4, and type this in, x to the second plus x plus 1, comma, and then the variable is x, close parentheses, and I hit enter. see it gives you an empty solution here. You have two braces here, a left and a right with nothing in it, so that means the solution set is empty. So that's telling you that there's no real solution. There's no real solution. But it does have complex or imaginary solutions that you can get using the other command. Okay, so that's why if you find the zeros of a polynomial, use that command, because that'll give you the non-real and the real. So sometimes your instructor or the instructions might say find the real zeros, or find the non-real zeros, or it might say find the rational zeros, or find the irrational zeros. Okay, well, the rational and the irrational fall under the real category. So either way, we use that command with the C, and we get all of them. Okay, and then you just give whatever it asks you for. So go F2 again. Complex, and over, and then I want number 3, hit 3, and then I enter this polynomial, x to the third minus x to the second plus x minus 1, and then define the variable, so comma x close parentheses, and then I go up here, the arrow key, so I can get the whole solution here. So it's 1, negative I, and I. So it has 3. Remember the degree of the polynomial, just like with equations, the degree of the polynomial tells you how many roots or solutions to expect, or in this case, zeros. So if it's third degree, we expect to have 3 zeros. They might be repeated, okay, but we expect 3. So in this case, we have 3 distinct zeros. One is real, that's the number 1, and then the other 2 are imaginary or complex, negative I and I. Okay, and this one concludes now. That's a short video. Just wanted to show you this setup, finding the zeros of a polynomial. So again, if these are helping you out, please subscribe to the channel, and I'll follow up with a few more videos on the TI-89, and then I'll go to something else. But again, your input is welcome, and we'll see you next time.